This video is about operation of complex numbers in polar and Euler form. Multiplication of two complex numbers. We multiply the modulus. We add the arguments. We can express this operation by using eigenplane. Suppose this is z1, angle is theta 1. This is z2. Argument of z2 is theta 2. Modulus of z1 is r1. Modulus of z2 is r2. This will be z1 times z2. Modulus of this z1 times z2 is r1 times r2. And argument is theta 1 plus theta 2. Let's talk about the geometric meaning of complex multiplication. R e to the power of I alpha 1 times e to the power of I alpha 2 equals R times e to the power of I alpha 1 plus alpha 2. Suppose this is alpha 1, R. This is alpha 2. This is R. Suppose this is z1 equals R times e to the power of I alpha 1. This is z2 equals R times e to the power of I alpha 1 plus alpha 2. Therefore, R times e to the power of I alpha 1 times e to the power of I alpha 2 means rotating R times e to the power of I alpha 1 counterclockwise alpha 2 angle. Now let's go to quotient of two complex numbers in polar and Euler form. Modulus will be divided by each other. The argument will subtract each other. This is a complex number z1. This is a complex number z2. Argument theta 1 for z1, theta 2 for z2. Modulus r1 for z1, r2 for z2. Then this will be z1 over z2. The modulus is r1 over r2. Argument is theta 1 minus theta 2. Let's talk about R times e to the power of I alpha 1 over e to the power of I alpha 2. So we get R times e to the power of I times alpha 1 minus alpha 2. Suppose this is z1, R times e to the power of I alpha 1. This is alpha 1. This is z2 with the modulus R. This angle is alpha 2. So for this z2 equals R times e to the power of I alpha 1 minus alpha 2. From this diagram, we could say r times e to the power of I alpha 1 over e to the power of I alpha 2 means rotating r e to the power of I alpha 1 clockwise alpha 2 angle. Let's talk about power of complex number in polar and Euler form. RCIS theta to the nth power equals r to the nth power CIS n times theta. We call this formula De Moivre's theorem. Let's go to guided practice 4. Perform the given operation and express it in Cartesian form. Multiplication of a complex number. We make modulus multiply. 6 times 4 is 24. Then CIS pi over 2 plus pi over 4 equals 24. CIS 3 pi over 4. Let's draw the argand plane. 3 pi over 4 go to second quadrant. Reference angle is pi over 4, so in the middle. Let's label negative square root of 2 over 2, square root of 2 over 2. This reference angle is pi over 4. So we get 24 times. Real part of z is negative square root of 2 over 2 plus square root of 2 over 2i. Distributive property, negative 12 for square root of 2 plus 12 for square root of 2i. Let's go to question 2. Negative 3 times 6, negative 18. CIS 45 degree plus 75 degree equals negative 18 CIS 120 degree. 120 go to second quadrant. Let's draw this argand plane. So alpha equals 180 minus 120 degree equals 60 degree. This is 60 degree. So longer leg is square root of 3 over 2. Shorter leg is negative 1/2. So we get negative 18 times negative 1/2 plus square root of 3 over 2i equals 9 minus 9 square root of 3i. Let's go to question 3. Quotient of these two complex numbers. 3 divided by 1 over 2. Jump to the top. 6. 6 CIS 3 pi over 4 minus pi equals 6 CIS negative pi over 4. Let's draw this argand plane. Negative pi over 4 go to fourth quadrant. In the middle, because these two legs are equal to each other. Square root of 2 over 2, negative square root of 2 over 2. The reference angle is pi over 4. Therefore, we have 6 times square root of 2 over 2 minus the square root of 2 over 2i. We got 3 square root of 2 minus 3 square root of 2i. Let's go to question 4. 7 over 6 CI as 135 minus negative 45 degree equals 7 over 6 CI as 180 degree. Let's draw this argand plane 180 degree. So we get negative 7 over 6. Let's go to 5, De Moivre's theorem. So we get 1 over 2 to the 6th power. CI as 6 pi over 4. We got 1 over 64. CI as 3 pi over 2. Argand plane 3 pi over 2. So we got negative 1 over 64i. Let's go to question 6. 2 over 3 to the power of 4. CI as 4 pi over 3. Let's sketch argand plane. Reference angle is pi over 3. Away from this x-axis, let's label shorter leg is negative 1 over 2. Longer leg is negative square root of 3 over 2. This reference angle is pi over 3, which is 60 degree. Work this out. 2 to the 4th power is 16. 3 to the 4th power is 81 times negative 1 over 2 minus the square root of 3 over 2i equals negative 8 over 81 minus 8 square root of 3 over 81i.